Let's see what is a model in this video. Model is simply a mathematical or computational representation of process or pattern learned from data. Let's break this down with an example. Let's say we have some data. So this data has some inputs and some outputs. This data could be anything, but in this example, imagine that the input is images and the output indicates whether that image is a cat image or a dog image. We call the output as label or classification, which basically says whether the given image is a dog or a cat. Now, something or someone maps this input to this output. So they'll take an image and they'll see what this image is and they'll say whether it is a dog or a cat. So it could be a human or it could be some other system. So something is happening, right? Something is happening to map this input, which is an image, to the output, which is a label. And this something, if we can mathematically or computationally represent what is happening to map this input to this output, then that is what called as model. Okay, now this model is different from traditional computation because we will not be able to explicitly specify the steps the system has to take to map the input to the output. We will not be able to specify that explicitly. The model has to figure that out just using the data. We'll pass a bunch of data, and from that data, it will understand what is going on. It will recognize how this input is mapped into this output, and then it should be able to do that on its own on any new data. If we provide any new image, the model should be able to classify whether that image is a cat image or dog image. Okay? This process of teaching the model to learn from data is called training or model fitting. Okay? Now, in order to create this model, we need two things. First, we need to pick an architecture or algorithm that is suitable for this task. When I talk about algorithm, I'm referring to things like decision tree or classification algorithms and stuff like that. And when I'm referring to architecture, I'm referring to things like neural network architecture and many other similar architectures that are used for creating AI models. So we need to pick an architecture or algorithm that is suitable for this task. Then what we will do is we will provide that, okay, so these are the inputs, and for this input, this is the expected output. Now go and figure out what you need to do internally to give me this output for this input. Okay, so we call this process as training or model fitting. So the training process will help the architecture or algorithm to learn how to map this input to this output. Once it has learned things successfully, i.e. it has recognized the patterns successfully, it will remember that pattern. Okay, so it will remember that pattern. Now, a model is combination of the architecture or algorithm that we have chosen plus the pattern that it remembers. Okay, so the combination of these two are called model. Why do we do this? Why this is useful? This is useful because once we have trained and created a model for a particular task, in this case it is classifying whether an image is a dog image or cat image, we will be able to use that to recognize or classify new images as well. Now if we have a new image and we want to classify whether it is a dog or a cat, we should be able to use the model to do that task. Okay, so that is why this model is useful. Okay, now just to repeat, the process of teaching the model to learn is called training or fitting, and at the end of this we'll have an architecture or algorithm plus the patterns or process that it remembers. The combination of these two is called a model. Okay, now to make this concept more concrete, let's see a few more examples. Let's imagine that this is the data we have. We have two input columns, A and B, and we have one output column C. If we take a deeper look here, we'll be able to recognize that C is just a sum of A and B. Okay. This particular problem can easily be solved using traditional computing. But let's imagine that we are not able to figure out how the output is created from input, because the data is huge and also the pattern is not so obvious like we have here in this example. Okay. In this case, what we will do is we'll pass A and B as training input and we will say that C is the output. Now, the algorithm or architecture, what it needs to do during training process is that it needs to figure out, okay, so this is the input I have and this is the output I need to produce. What do I need to do internally to make that happen? So similarly, it will be able to do that for all of these examples. We'll call these as training inputs. And hopefully, by the end of it, it will be able to generalize it. It will be able to figure out that what really happens is we are actually summing A and B together to get C. So hopefully it will be able to figure that out and it will remember that pattern. Once that has happened, if we pass in any new input, for example, if we pass in 6 and 3, it should be able to tell us that the output is 9. Okay, so that is what we are trying to get out of these models. Okay, let's see one more example. So let's imagine that we have some data, and if we plot the data in XY coordinates, this is what we see. We have some yellow circles and we have some red squares. Let's imagine that this is output of some experiment. Okay, so according to that experiment, yellow circles are good results and red squares are bad outputs. Now, we want to classify whether the output of an experiment is a good output or a bad output. Okay, and for that we are trying to develop a model. Okay, we will be able to pass this as an input to a model, and the model will be able to figure out the pattern here. Hopefully it learns that it needs to separate the data like this. Once it has done that, once it has learned this pattern, if we provide any new input, okay, if we provide any new input, probably from the latest experiment, the model will be able to tell us whether the experiment outcome is good or not. Okay, because it has recognized this pattern. So anything falls above this green line is good, anything that falls below this green line is bad. So this is what a model does. So this is what a model is all about. Just to repeat, a model is mathematical or computational representation of process or pattern learned from data. Okay, all of these are data, and from this data we create this model, and this model is going to help us to produce the output from any new input which is not used for the training. Okay, so I hope this is clear and this video is useful. Thank you.